part I says determine the non-permissible values, I'm going to actually do the non-permissible values after the proof. Because sometimes the proof helps us see non-permissible values easier. The non-permissible values are always going to be based on what are you not allowed to do. You're not allowed to divide by 0. So when I go to this and I prove it, so let's do the proof first. We're going to prove in part A that cotangent of theta over cosecant of theta is equal to cos of theta. So we rewrite up the question, draw the line. Can we change things to sine and cos? Yes. Do we? I always take a look at it. Before I do that, I say, is there anything else that I think might be faster? No, I don't really see anything. So I decide I'm going to change cotangent to cos theta over sine theta. Draw a thicker line for my main line. 1 over sine. I have a fraction divided by a fraction. I can multiply by the reciprocal. Have a common thing, it cancels. Yay! Oh, I like that pen. I'm going to use that pen. I like that D. That looks cool. Okay, so we proved it. Now, as far as looking for non-permissible values, check. I'm going to take out my highlighter. I'm going to look. Here I'm dividing. Here I'm dividing. Here I'm dividing. I look at all the places that I'm dividing. So what do we have for non-permissible values? We know that sine of theta can't equal 0. Because if sine of theta equals 0, I divide by 0. So I can solve this by then saying, well then theta can't equal, where on our pi plate is sine equal to 0? 0, pi, 2 pi, or theta can't equal all the zeros of sine, which is k pi, where k is an integer. Remember in chapter 6 when we listed all the zeros of sine? Now we have a place in chapter 7 where we have to solve that again.
Did we write that on the page or not?
On the test tomorrow, they might ask you on the test tomorrow, what are the zeros of sine? Or not Monday?
Tomorrow, I was about to say.
Sorry, sometimes I think of school days as just the next school day is tomorrow.
You're bad.
Right? Second one. Let's prove it first. I look, okay, don't see anything short. I can change everything to cos, but that's the same strategy as changing things to sine and cos. This side is going to stay cos theta. This side, I can change that secant to 1 over cos. And do you see that you now have fractions inside of fractions? Fractions inside of fractions. Get a single fraction on the top. And I like this question because lots of students don't see that the top technically is all over 1. It is a single fraction. Can you see yourself not seeing that? Okay. The bottom, though, I need a common denominator in order to add fractions. I multiply the top by cos, the bottom by cos, and then I would get cos theta plus 1 over cos theta. And now I have a single fraction on the top, a single fraction on the bottom. So fraction divided by fraction. Oh, look at that number. That's so nice. Multiply by the reciprocal. That was crazy.
How is that so much?
What's going on? It's a ghost. It's Halloween. The ghost of this math class just does. I really know no mathematics, but there's this ghost that takes over me and teaches you. That's what's happening. Yeah, and that time that I beat up that student, that wasn't me, that was the ghost.
Okay.
I turned it on mute, so that's not on the video. All good. And then the 1 plus cos thetas are identical. Simplify them, and you're just left with cos. So
That's so scary. I don't know that.
well, this is the ghost thing where right. There we go. So now non-permissible values, I'll take out my highlighter and I need to check, did we ever divide? Yes, we're dividing here. And then we're dividing here. So as far as non-permissible values, which we sometimes use NPV, we know that cos of theta can't equal 0. And we know that cos of theta can't equal -1. So this will be you can either, you remember we could either write it this way, or we wrote it odd numbers of pi over 2. And cos of theta is equal to -1 just at pi. And so everything coterminal with pi would be pi plus 2k pi. So out of your textbook, for questions 1 and 2, you can do 3, 4, 5, 6, and then in 7, just do the prove part. In 8, just do the prove part. In 9, just do the prove part. And 11. So you'll get more practice proving